This is one of a series of revision lectures produced by the Further Maths Support Programme for AQA. In this particular lecture we're looking at the D2 specification and the January 2010 paper question number 3. This is a question about game theory. We're told that two people, Anne and Bill, are playing a zero-sum game, and the game is represented by the payoff matrix for Anne. We're asked to show that this has a stable solution and to state the play safe strategies for Anne and for Bill. In the second part of the question we have another game. This time it doesn't have a stable solution, and we have the payoff matrix for Russ. We're asked to find the optimal mixed strategy for Russ and to find the value of the game. So in the first part of the question then, we have the payoff matrix for Anne, and we need to look in here for the row minima for Anne. So this will be the row min values, and if we look at those we can see that we have -2, -3 and -5 in each of those rows. So the maximum of those is -2. So this is what's called the maxi-min value, or the row maxi-min. If we then do a similar thing looking at the columns, the column maxima, so these are the largest values in the columns. They are 4, 0 and -2. This time we want the minimax, so that this is the column minimax value, or the smallest of those, and that's also equal to -2. So we can see that the row maxi-min is equal to the column minimax, and therefore we have so we can say that these are equal, and therefore we have a stable solution, in which case Anne plays strategy A1 and Bill plays strategy B3. The marking for that part of the question then was a B1 mark for looking at the row minima and the column maxima, a method mark for looking at the maxi-min and the minimax and saying that they were equal and therefore stable, and a single mark for giving the actual strategy. In the second part of the question we're told that we have a new game, and this time it is not stable, and we're asked to find the mixed strategy for Russ. So in this then the procedure is to say, well, let's Russ play each of his strategies with a probability p and therefore 1 minus p, and look at what happens if Carlos plays each of his strategies and see what the expected gain is for Russ. So we can say that if Carlos plays a strategy C1, then we can look at Russ's expected gain, and from the table that will be -4 multiplied by p and +2 multiplied by 1 minus p, or in other words that's 2 minus 6p. Doing a similar thing for C2, we get 7p plus -1 times 1 minus p, which is equal to 8p minus 1. And for C3 negative 3p plus 1 times 1 minus p, which is the same as 1 minus 4p. So these are the three different things that can happen. And we indicate those on a diagram showing the probability going from 0 up to 1, so p varying from p up to 1. So here's my diagram, and if I put in the probability here along this line going from 0 to 1, and we're going to put in lines indicating each of the different outcomes. So for C1 we're going to start off at a value of 2, so just marking that on my diagram here at 2, and if we put p equal to 1, we can see that the expected gain is 2 minus 6, which is negative 4. So we need a line going from 2 down to negative 4. It's worth indicating on your diagram that that line there comes from Carlos playing C1. Moving on to C2, when p is equal to 0, that will be equal to negative 1, so we're going from negative 1 here. And when p is equal to 1, we've got 8p minus 1, so that will be up to 7. So we've got a line there going from negative 1 up to 7. And that line came from C2. C3, when p is equal to 0, it starts at 1. And when p is equal to 1, we get down to negative 3. Well, if we now look at our graph, we can see that the point that we need is this one here. It's the highest point, which is below all of these lines. So it then starts to go down. So it's this one here, which is the intersection of C2 and C3. So we now need to solve the equations that come from C2 and C3. In other words, 8p minus 1 is equal to 1 minus 4p. And if we do that, 12p is equal to 2, and therefore p is equal to 1/2. I beg your pardon, p is equal to 2 divided by 12, which is 1/6, of course. So we can see then, therefore, that the mixed strategy for Russ that we're asked to find is that Russ should play R1 1/6 of the time, so with probability 1/6, and his other strategy R2 with probability therefore 5/6. The value of the game comes by simply substituting the value of p into one of the equations. So for example, we can take the 8p minus 1. So with p equal to 1/6, 8p minus 1 is equal to 8/6 minus 1, which is equal to 2/6, or 1/3. And that's the value of the game. The marking for this part of the question then, there was a method mark and a mark for getting these equations, a method mark and a mark for drawing the graph, a method mark and a mark for getting the probability equal to 1/6, and then explanation mark for the strategy that Russ should play, and finally the value of the game was given a single mark, B1. Well, that's the end of this particular question. If you'd like to see other questions, you can find them at www.furthermaths.org.uk.